All right, so now we're second part of solving inequalities, except this time is with multiplication and division. Okay, when do you reverse the inequality symbol? This one tends to be, of the two, more challenging, but it's not really that much more challenging. Let's take a look. Look, when you multiply and divide with a positive number, okay, A is greater than B, you multiply both with the same, it still stays the same. It's going to be fine. Nothing changes. Okay, for instance, 5 is greater than 2. If I multiply both by, oh, I changed some numbers here. If I multiply both by 4, that would be 20 is larger than 8, and that still stays the same. Okay, sorry, I don't know what I was thinking there. So that's nothing changes. Okay, if I multiply or divide by a positive number, you just go ahead and continue to solve it. Everything is fine. Example number 1, look, I've got this value. 6 times the number is less than or equal to 42. If I divide both sides by 6, I end up with the answer 7. Close circle at 7, everything less than that. Then I check. When I check, I'm just going to pick something super obvious. 0 is obviously less than 7, so 6 times 0 should be less than 42, and it is. It's less than or equal to that. Let's take a look at another example. Okay, I'll just show you all my work here. M divided by 2 is greater than 10, so I multiply both sides by 2. M is greater than 20. Any number bigger than 20. All right, so this time I just chose 22, okay, just to check. 22 divided by 2 is 11, and 11 is greater than 10. So yes, that is correct. Open circle at 20, shaded that way. The only time things change is when you multiply or divide by a negative number. So watch out, negative numbers, okay? If you multiply or divide with a negative number, you must reverse, okay? Reverse the inequality symbol to remain true. Okay, why is this? Because look, remember negatives are just kind of asking for opposites. So if x was larger than 10, the opposite of that, if I said, hey, go ahead and multiply those by negatives, the opposite of that would then change the direction, right? It would change the direction. So keep that in mind. Opposite is asking for really opposites all over the place. So let's assume that c, value for c, is less than 0. In other words, it's a negative number. Then this would be the case. A is greater than B, and if you were to multiply both of them by a negative number, that's what C represents here, then what needs to happen is this needs to get flipped around. Okay? Those two get flipped around. Again, if A is less than B and you decide to multiply by a negative number, you need to switch the signs. Whether you divide both by a negative or multiply both by a negative, you must switch the direction of the inequality. All right, so that's using algebra. Let's actually look at some numbers here. Okay, 6 is greater than 2. We know that. If I multiplied both sides by negative 2, right? That's what this is showing here. If I multiply both by negative 2, look what happens. 6 times negative 2 is negative 12. 2 times negative 2 is negative 4. All of a sudden, the left side is not larger than the right side. It's reversed. The right side is larger than the left side. So that's why we reverse or switch the symbol. Let's take a look at another. If I divide, okay, so negative 9 is less than 27. We know that. If we divide both sides by negative 3, look what ends up happening. This and this turns into 3. This and this turns into negative 9. Okay, all of a sudden, the left side is no longer smaller than the right side. It's reversed. The right is smaller than the left. So we switch directions. So again, why is that? Because I multiply by a negative or I divide by a negative. Only with negatives, right? Switching the sign, switching your ideas, it flips around. So let's say the Duarte Community Pool charges $4 for each visit. You can also purchase a pool card. So if you want at the beginning of the summer, you can buy this pool membership, 3 months for $100. My question to you is, at which point, how can you use your inequality to find out when it's a better deal to spend the $100 or just pay $4 each time? Because right now, I'm going to pay $4 each time. But after how many times would it be better to have the membership? So what I do is say, look, I'm going to spend $4 each time. Okay, spending $4 for each visit that I go. And I want to know, when is that going to be less than or equal to 100? Because if it's equal to 100, maybe I'll just keep doing that. But if it's less than, I'm going to keep working, keep going to the pool this way. But if it's more than that, then I know, hey, it's better to get the deal. So divide both sides by negative 4. Notice what happens to the inequality symbol. It does switch, okay? And I end up with V is greater than or equal to negative 25. That just basically is telling you, look, if I'm going to spend $4 a visit, I can do that up to 25 times. After that, it's going to be better to buy the pool membership. It'll be cheaper, okay, because I've already spent the $100 and I won't have to spend any more. And so that's how we can solve that.